This is critical thinking on epithelium and connective tissue. So let's look at the questions. So here we have something about the types of epithelia, and then here is more on the function, and here we have something on tendons and hence connective tissue, and again this is bone and cartilage, and again we're looking at connective tissue. So let's look at this one. And it says, which of the epithelia below is stratified and can change its height? Now, remember, squamous and cuboidal are simple epithelia. Squamous is just a single layer of basement with squamous cells, very flat cells. So, all epithelia have this basement membrane. So this is not stratified, single layered. Cuboidal, here again you have basement membrane, the cells are as tall as they are broad, and here's the nucleus. So again it is single. Transitional epithelium, this is the epithelium which is stratified. That means it is multi-layered, and again if you remember, you have a bottom layer of cells, and then you have cells which are pear-shaped up here like this, and then you have umbrella-shaped cells, plump cells at the top, and there are spaces in between, and these cells dip into these spaces when the epithelium is stretched. So when the epithelium is not stretched, this is probably the height. Now when the epithelium is stretched, these dip and go down, so the epithelium actually gets a little lower. So this is the epithelium which can change its height. So let's say it becomes this way. So this is the correct answer. And sometimes when you look at, even if you know where the epithelium is present, you will be able to come to the correct answer. So I'll come to that. So let's look at this one, stratified, squamous, keratinized. It is stratified epithelium. So it has these numerous layers up here, and then there is keratin on top. And this one is non-keratinized, so it has all of this without the keratin. Now this is seen in areas like the esophagus, and it is seen in areas like the anal canal, the vagina, all the wet areas. Keratinized epithelium is skin. That's where it's found. Transitional epithelium is seen in the urinary tract, in the ureter and the urinary bladder. Now look at this, the urinary bladder has to stretch a lot in order to store urine. So therefore that also makes if you know what the function of the epithelium is, and you know where it is present, and you relate the two, you often come to the right answer. So that's why in this case this is the right answer. And you can see how either knowing the function of transitional epithelium, or if you forget that and you know where it is and you kind of work your way backwards, you can understand that way. Skin, the epithelium doesn't need to sort of stretch and become shorter or longer, so obviously it's not present here. And the same for this area, the keratinized epithelium. So therefore transitional is the right answer. Let's look at this question. What type of epithelium is best suited to line the Bowman's capsule of the kidneys where filtration takes place? Now, where filtration takes place, it means that substances, so let's say that this is the epithelium, or let me just draw the Bowman's capsule. The Bowman's capsule looks something like this. And then, there are capillaries present here inside, which are known as the glomerulus. And from the capillaries, fluid has to pass out, pass through, and come down here. Naturally, when fluid or anything has to pass through, and filtration is something where substances have to pass through, you don't want the epithelium to be thick. If it was thick, it's going to be very difficult for filtration to occur. So therefore the correct answer to this question is squamous epithelium. So imagine if it is lined, if the Bowman's capsule this way is lined by squamous epithelium, and then the blood vessels are also lined by squamous epithelium. Only thing is it's called endothelium there. So can you see it very easily, the fluid can pass out this way. Cuboidal is too thick because imagine the cells are this way, so it has more distance to pass through. Columnar, even thicker, and you don't want stratified epithelium anywhere where substances have to pass through like that. This is the other reason why even alveoli of the lungs, where gas exchange takes place. So if you look at the air sacs or alveoli of the lungs, and in between you have blood vessels, and so this is the squamous epithelium of the alveoli, this is that of the blood vessels, and oxygen goes in from the alveoli into the blood vessels and carbon dioxide the other way around. So they have the distance which they have to pass through is very little. Hence, even alveoli have squamous epithelium. So this is how you must think when you answer questions like this. Let's look at this question. It tells you the tendon of the biceps brachii would be composed of. Now, tendons are first of all composed of connective tissue, so you can discount with this. The connective tissue has to be dense and it has to be together. So adipose tissue is loose connective tissue. It's not going to be here. Tendons, and when you look at any muscle and you look at biceps brachii and look at tendons, you see it's very orderly. The forces have to act in one direction only. So therefore it is made up of dense regular connective tissue. Dense irregular connective tissue is present in an area where you have, where connective tissue is kind of in all different directions, but it's densely placed. So because it has to withstand forces from all different directions. For example, capsules of organs, capsules of joints, all this will have dense irregular. But things like tendons, ligaments, aponeuroses, where the forces are in one direction only, will have dense regular connective tissue. So the tendon has dense regular connective tissue. Now let's look at the last question here, which tells you about fractures and why they heal faster than tears in the cartilage. And let's look at this. So the first choice is bone has cells which lay down matrix, which is, yes, osteoblasts, and they lay down matrix. But then so does cartilage. Cartilage also, while this is a true statement for bone, but remember, that's not why they heal faster, because cartilage also has cells, or chondroblasts, which lay down matrix. So that's not the right answer. Now think of this one. Bones have lamellae. By itself, it's a true statement. But having lamellae does not give it an advantage to heal faster. So that's not the right answer. The next one, cartilage lacks perichondrium. Now, all cartilage does not lack perichondrium. It's only articular cartilage and fibrocartilage which lacks perichondrium. So, therefore, this cannot be the right answer. Then this one, fibers are not seen in cartilage. This is wrong because connective tissue by definition has fibers. It's only in hyaline cartilage fibers are present, collagen fibers, which are the ones which give it great strength. But you just don't see them in a slide because their refractive index is the same. So let's look at this last answer. And so, you've discounted all of this and you come to this. So even if you didn't know, this would be the right answer. And it just so happens it is, because bones have a very rich blood supply. So when they have a very rich blood supply, that helps in healing. Cartilage is avascular. It depends on diffusion for its nutrition. So cartilage does not heal as fast. In fact, in some areas it may not heal at all if there's a tear. So therefore, this is the correct answer for this question. So whenever you're looking at choices, this is how you kind of should go through all the choices and come, sometimes by the process of elimination, you come to the right choice, even if you didn't know that that is the one that you should have chosen. Okay, so I hope this helps you with the first part of the tissues quiz.